Welcome, my dear learners, to another exciting episode on Stable Tutorials. In today's lesson, we shall be looking at triangles. But before that, let's look at the lesson objective for today. So by the end of today's lesson, you, my students, should be able to state the types of triangles and their properties, and then you should be able to apply the properties of triangles in solving questions on triangles. So without wasting time, let's set the ball rolling. But before that, like, share, and subscribe to this very channel for more updates. So we are looking at triangles. Now, triangle is a special type of polygons with 3 sides and then 3 interior angles. So when you have any plane figure which is bounded by 3 sides and then 3 interior angles, then we can classify that plane figure as a triangle. So looking at this plane figure, it has this side, and this side bounded together, and this plane figure has 3 sides. Now it also has 3 interior angles. So you can see one interior angle here, another interior angle here, and then another interior angle here. So you can say that this plane figure is a triangle. Now, the sum of this interior angle is equal to angle on a straight line. This means that when we detach or we cut these angles and then we arrange them on the straight line, it is going to fit exactly. So let's go through this activity to find out. So these are the angles that we have detached from the triangle. So this is the triangle. These are the angles that we have detached. We are going to arrange them on the number line. So you realize that after arranging the angles cut from the triangle on the straight line, it fits exactly. So you can see that the angles that were cut from the triangle lies exactly on the straight line. So we can say that the sum of interior angle of all triangles is equal to angle on a straight line. And angle on a straight line measures exactly 180 degrees. So we can say that the sum of interior angle of every triangle is equal to 180 degrees. Are you following? Good. So this angle plus this angle plus this angle should give us what? 180 degrees. Are you following? Good. We are going to look at the types of triangles that we have. Types of triangles. So we are looking at the types of triangle. Now triangle has been classified by their angle and then by their side. Now by their angle, we have the right angle triangle, the acute angle triangle, and then the obtuse angle triangle. And then by their sides, we have the equilateral triangle, isosceles triangle, and then the scalene triangle. Is that clear? Good. Now by the angle, we are starting with a right angle triangle. As the name implies, right angle. So a right angle triangle, it is a triangle with one of its angles being equal to 90 degrees. So this is a right angled triangle because it has one of its angles being equal to what? 90 degrees. And then the remaining angle are acute angle. Now the next on the list is an acute angle triangle. Acute angle triangle. So an acute triangle, it is a triangle with each of the interior angle being less than 90 degrees. So when you have a triangle with the individual angles within the triangle being less than 90 degrees, then we can say that that triangle is an acute triangle. Good. The next on the list is the obtuse angle triangle. The obtuse angle triangle, it is a triangle with one of the angle being an obtuse angle. So we have the obtuse angle. So this is the obtuse angle triangle. It is a triangle with one of its angle being an obtuse angle and the remaining angles being an acute angle. So these are the types of angles that have been classified based on their angle. Now what we are going to look at is their classification based on their size. So we are looking at the classification based on their side. And then the first on the list is the equilateral triangle. Now this is the equilateral triangle. It is a triangle with all the sides being equal and the interior angles to be equal. So let's look at the properties of the equilateral triangle. Now one of the properties is that all the sides are equal, and most at times it is indicated with a stroke. All the sides are equal. So we have one, all sides are equal. And then two, all the interior angles too are equal. So if this angle is 60 degrees, this angle is also 60 degrees, and then this angle is also 60 degrees. So it has its interior angles being equal to 60 degrees. Each of the interior angle is equal to 60 degrees. So it has all the angles being equal, all angles are equal. And then it has three lines of symmetry. Now when we talk about lines of symmetry, then we are referring to a line that cuts a shape into two equal halves, such that if we are to fold it along that very line, those two halves will lie on each other without each of them elapsing. So I said that it is a line that cuts a shape into two equal halves, such that when we are to fold that shape along the line, each of the halves will lie on each other. So this is an equilateral triangle that I've cut. Now we are going to determine the number of symmetry it is going to have. So let's fold it along this very angle. So let's fold it and see. So after folding it, we realize that each of the halves lies on each other. So we can say that this is one of our line of symmetry for the equilateral triangle. Now let's fold it from this very angle. Okay, so we've gotten one line of symmetry. So let's fold it this way. So after folding in this way too, we have another line of symmetry. Good. Now let's fold it in this way too, from this very angle. So after folding it in that way too, we have another line of symmetry. So you can see that we had this, and then this. So an equilateral triangle has 3 lines of symmetry. So it has 3 lines of symmetry. So that is that for equilateral triangle. Let's move on to isosceles triangle. Isosceles triangle. So this is an isosceles triangle, and I have it here. Let's look at some of the properties of an isosceles triangle. Now, one of the properties is that it has 2 sides being equal. If you have to take a rule and measure this length and this length, you realize that this length is equal to this length. So you can say that it has 2 sides being equal. So we can say one property has 2 sides being equal. It also has 2 of the base angles being equal. So 2 of the base angles too are also equal. Then let's talk about a line of symmetry. So let's try to fold this triangle to see if it is going to lie on each other. So let's fold it from this very angle. So we have it like this. Okay, so we are having one line of symmetry here, which is this very part. So realize that each of the halves is lying on each other. So this is our line of symmetry. Good, so we have gotten one. Now let's fold it from this very angle and see. Oh, so after folding it, realize that each of the halves are not lying on each other because we have this part being far away from this very part. They are not lying on each other. So this is not part. Let's try to fold it in this very part. So this part too doesn't fit each other. So we only have one line of symmetry for the isosceles triangle. So it has only one line of symmetry. Good. So that is that for the isosceles triangle. Has 2 sides being equal, has 2 angles being equal, and then only one line of symmetry. Now, the line of symmetry, most of the time, it is indicated like this. So this is the line of symmetry, and then for the equilateral, it's like this. So we folded it along these very angles. So it has 3 lines of symmetry, 1 line of symmetry. Then let's move on to the scalene triangle. So scalene triangle. So the scalene triangle is a triangle with none of its sides being equal. So none of the sides of a scalene triangle are equal. It has different sizes, and none of the angles too are equal. And also, it has no line of symmetry. So the properties we have: no sides being equal, no angles being equal, and then no line of symmetry. So these are the very few properties of triangles that we have based on their size that we have. So we are going to base on these angle properties to solve questions on angles. So these are our examples. We have to find the angle marked with letters. So we have our I and then X. We are going to find the value of this unknown angle. So looking at this very triangle, what type of triangle do you think it is? So realize that we have two straight lines here, two stroke of lines here, and this indicates that this triangle is an isosceles triangle. And some of the properties of isosceles triangle is that it has two lines being equal, and then the base angles too are equal. So these are the base angles and they are equal. So we can say that our x is equal to 70 degrees. Do you agree with me? Now that we know this angle to be 70 degrees, we can apply the interior angle of a triangle to find the value of y. So we can say that we have x plus 70 degrees plus y is equal to 180 degrees. Now we already know that x is equal to 70, so we have 70 plus 70 degrees plus y is equal to 180 degrees. 70, we have 140 degrees plus y is equal to 180 degrees. So we can say that our y is equal to 180 minus 40, 140. Therefore, our y is equal to 40 degrees. Very, very simple. Now, I want you to try your hands on this. Find the value of x and then angle A. Try your hands on it, and then we take another example. So, I hope you were able to find the value of x. Let's go through. So, we are going to get 2x plus 3x plus 4x is equal to what? 180. Sum of interior angle of a triangle. So, we have 180 degrees. So, we have 2x, 3x, 4x. We are getting 9x is equal to 180 degrees. We divide both sides by 9, both sides by 9. 9 and 9 will go. 9 into 180, we have our x is equal to 20 degrees. Now the next variable that we have to find, or the next angle that we have to find, is this angle, which is represented with A. So we can say that, looking at this, we can say that this angle and this angle are adjacent angle, or angle in a straight line. And angle in a straight line sum up to 180. Therefore, this angle plus this angle should give us what? 180. So we have 3x plus A is equal to 180 degrees. Now, we have already established that our x is equal to 20 degrees. So we have 3 multiplying 20 plus A is equal to 180 degrees. 3 times 20 is 60 degrees plus A is equal to 180 degrees. So A is equal to 180 minus 60 degrees. Therefore, our A is equal to 120 degrees. So we have our A to be 120 degrees. Very, very simple. So this is our last example. We have to find the value of the angles marked with letters. This is a very simple question, and let's go through it. So looking at this very diagram, or considering this diagram, let's separate the triangles one after the other and then see how best we can solve it. So looking or considering triangle ABC. So considering triangle ABC. So let's draw it here. We have X, we have this, we have that, and then we have 90 degrees. So we have A, B, C. Now looking at this triangle, we have two lines being equal, and then we have a 90 degrees. So it makes the question very simple. So we know that since we are having two lines being equal, it is an isosceles triangle, and therefore the base angles are equal. So you can say that this angle is equal to x. So let's call this angle x. Good. So after getting x, and 90 degrees, we can use the sum of interior angle of a triangle to find the value of x. Do you agree with me? Good. So you can say that x plus this is 90. We have already learned about that. So we have 90 degrees is equal to 180 degrees. So x plus x, we have 2x plus 90 degrees is equal to 180 degrees. So by means of transposition or finding the additive inverse of 90, we are going to get 180 minus 90. So we have 2x is equal to 90 degrees. So dividing both sides by 2, we have this and that. 2 into 90, 45. So we have our s is equal to 45 degrees. Good. So this angle x is 45 degrees. And then we have to find angle marked with what? Y. So we know that this angle is also equal to x and is equal to 45 degrees. Okay, so let's write this angle to be 45 degrees. Now, before we can find angle W, we have to find this angle first. Okay, so before we can find this angle, let's use angle on a straight line to find this very angle. So you know that this angle plus this angle should give us what? 180 degrees. Good. So we have 45 plus, let's say, angle ACD is equal to 180 degrees. So angle ACD is this very angle. So you can say that angle ACD is equal to 180 minus 45 degrees. So our angle ACD is equal to 135 degrees. So this angle is 135 degrees. Good. Now that we know this angle, let's consider triangle ACD. Triangle ACD. So let me draw it here for you to see it clearly. So we have A, C, D, we have this, that, and then we have W. But this angle is 135 degrees. Good. Now looking at this very triangle, what type of triangle is it? Now realize that we have two of the sides being equal. Therefore, the base angles too are equal. Sorry, this angle is Y. So the base angle is equal. So this angle is also equal to this angle. So using the sum of interior angle of a triangle, we can say that this angle plus this angle plus this angle should give us 180. So we have y plus y plus 135 is equal to 180 degrees. I hope you are following. Good. So we know that y plus y will give us 2y plus 135 is equal to 180 degrees. Now the next thing we are supposed to do is to find the additive inverse of 135 or transpose 135 to the other side of the equation. This is simple algebra. So we have 180 minus 135. So we have our 2y is equal to 45. Good. Now we are looking for y. We divide both sides by 2. Both sides by 2. This and that will go. So you can say that our y is equal to 22.5 degrees. And that is that for y. Good. Now that we know the value for y, we can find the value for w by applying angle on a straight line or adjacent angle. Try your hands on that, and I know you can find it. So these are a list of questions that are prepared for you. You can pause the video, write them down, and then you try your hands on this. This brings us to the end of today's lesson. Kindly like, share, and subscribe to this very channel for more updates. See you next week. Bye bye.